Isn't it amazing that about 70% of the surface of the planet is this ocean, and that the processes going on in the ocean also affect much of what happens here on land? But what exactly is going on under those waves? And how do these processes affect us? Let's dive into these questions with some expert help. Come on, let's go.
So here's Scripps, Institution of Oceanography. Scientists study everything about waves and the cycles of the ocean. Come on.
So to find out more, we tracked down oceanographer Yvonne Fehring at Scripps Institute of Oceanography in San Diego.
So I saw you out there, and I have a question. Where did these waves come from that you're surfing?
Well, some of the smaller waves are locally generated wind swell, but some of the set waves, the bigger waves, were coming from all across the Pacific, maybe from the South Pacific or Central Pacific, and they've traveled all the way across to reach us here and break.
So a wave is moving all that water right from where the storm is all the way over to here where it's breaking on the beach?
Not quite. The wave is just an up and down motion of the water, and the energy of the wave and the shape of the wave moves all the way across the ocean, but the water actually stays where it is. The water goes around in circles as the wave moves by.
So it turns out that when waves travel, the water particles actually move in a circle and remain in pretty much the same place. So it's a transfer of energy rather than movement of water until the wave breaks. Yvonne tells us that the speed of a wave is dependent on the water depth, and in shallower water, the wave moves slower and a form of friction is created between the bottom of the wave and the bottom of the ocean. This builds up the wave and it gets steeper and steeper until it breaks, and a breaking wave will move water forward. Our surfers can explain this well. When they're waiting for a wave, they only move up and down with the rolling waves, but when a wave builds up steep, then they can ride with it.
So what other things can cause waves?
Well, one other thing that can cause waves is a landslide, a volcanic eruption, or an earthquake, and that leads to a wave called a tsunami. So a tsunami is a very high energy wave, but when it's in deep water, it's very small. It's only when it gets into shallow water that it becomes tall, and it can push water very far, and then it causes flooding.
Tsunamis have sometimes wrongly been called tidal waves. This is misleading since the tides and tidal waves are actually caused by the gravitational pulls between Earth, the Sun and the Moon, which is of course very different to tsunamis caused by earthquakes and landslides.
Alright, so we learned that wind and earthquakes can create waves, and gravitational pulls of the Sun and Moon generate the tides. But the movement of water in the ocean is also affected by large, more or less continuous global currents.
The global ocean currents are partly caused by prevailing winds, but also by the movement of warm and cool water masses, because cold and warm waters have different density. One example is the Gulf Stream that circles the Atlantic. The Gulf Stream starts in the Gulf of Mexico, moves northeast carrying warm waters from the Caribbean, past Florida, then eastwards towards Europe, like an 80-kilometer wide river flowing at about 2 meters per second, which is actually fast enough for ships to hitch a ride on. And when the warm current reaches the cold polar regions of the north, the water cools down and sinks, recirculating the water south.
So it seems that waves are just one of the many factors that set the ocean in motion. Wind, currents, and tides move water in the ocean too. The oceans are just so important. They're always changing and moving and full of life, which is another great reason to never stop exploring your world. Now here's an experiment. See if you can create something similar to ocean currents. Take a few colored ice cubes and put them in a glass with tap water. When the cubes melt, where does the cold water go? If it goes down, imagine that warm surface water is filling in where the melted cubes were, creating circulation.